So I welcome you back to our YouTube channel where we are going to talk about graph reasoning vision models for real-time waste valuation and incentive-based sorting. So in our model, we are simply going to do three things: anticipation, valuation, and incentivization. So what are we going to do with the part of anticipation? We are going to have a model that can establish how much waste do we think is going to be generated in a specific part. Remember, the waste that is collected, let us say like from the central division of Kampala, cannot be in the same quantity as that is collected, let us say, in Kawempe division, because the number of people that stay in central division is smaller than those that stay in Kawempe division. So due to those differences, we are going to create a model that can anticipate waste generation in those different areas. Then to the point of valuation, we shall try to assess how good is the rubbish that we have sorted, the waste. How good is it? Let us say if it is plastic, is it only plastic, or it also has, let us say, like you've mixed it with organic waste? If let us say it is miscellaneous waste that can be misclassified, like let us say medical syringes, have you taken labor to ensure that you have disposed it of well? Then with the incentives, we are going to ensure that everyone that is helping us in the system can actually gain from the system itself through rewards of points. Then those that will not meet our standards will be negatively rewarded through deducting of points. So this is the content of what we're going to talk about throughout our presentation. My name is Benedict Wandera, and I'm going to be presenting. A colleague of mine also joined me later to add on to what I will have given you. So, from the beginning and the background as to why we took this. Remember, waste management is something that is hard because you cannot really give someone a reason as to why to store their rubbish well. So since you cannot give someone a reason, why don't you create for them an incentive so that they can gain from proper disposal of waste? Because poor disposal of waste will lead to various community hazards, let us say like health hazards and also other hazards. So to avoid that, create a channel where someone will be rewarded for proper disposal of waste. So it is with that idea that we came up with our project idea, which is EcoVerse, which is mainly going to enhance this through incentivization, valuation, and anticipation. So that is where we saw the gap to come up with EcoVerse, because what was in the market was majorly collection-based. And if it is collection-based, convincing someone when you're simply collecting is also hard. So due to the global approach that is being used in other countries, let us say like Germany, where the people are paid back money for disposing of plastic waste well. So with such incentives now put in Germany, you're going to find that most of their environments actually lack plastic waste and other types of waste because they have an incentive where they gain. So if we could also extend the same system to African countries like Uganda, we could also have the same thing to avoid problems like the Chitezi landfill that exploded and killed people. So, and through that, we shall be enhancing what we call a circular economy. Through the circular economy, we say we recycle everything that is being used. Through things like plastic bottles, we can recycle them to make, recycle plastic bottles to make filaments for 3D printers, which they can use to print other products that can be modeled for different use. So when we had this, we also came up with, let us say, problem statements. One was a domain application problem, and the other was computational problem. Then, as you saw, the domain application. Why would someone want to associate themselves with waste? So with this, we came up with what we call incentive-based waste management. Simply give them a reason. If someone can get back some of their money, then they're going to come back giving you the rubbish when it's well sorted. Then misclassification of overlapping waste. This ensures that Since you also want to get the money, classify the waste well, so that as we take it to the companies that are going to recycle it, it's going to be well classified. So for the computational problem, we are going to simply have graph-enhanced large vision models to classify all the data and avoid misclassification of things like organic waste and medical waste, since they are harmful to everyone. Then we should also try to scale it down so that it can fit on devices that can be easily handled by people, let's say like smartphones. So we came up with our objective question, our research questions and the objectives. So how can the large vision models improve real-time waste classification in Uganda? How can graph reasoning address overlapping? So through the large vision models, we are going to ensure that everything that is classified as rubbish has a sector where it falls, be it plastic, be it organic waste, be it medical waste. Then through graph reasoning, we shall ensure that we do not have spillovers, like let us say a medical syringe being classified as a plastic, yet it is medical waste, and other things, let us say like organic waste. Then, how does the incentive drive lead to sustainable waste practices? Why wouldn't you do something? Imagine all those people that were collecting rubbish now could, because right now they are simply paid because you collect, but everyone will despise them because they say it is a dirty job. But imagine if you're being paid something, let us say like you're being given a token of appreciation for simply collecting your rubbish well, then that means every citizen would want to do it since it is beneficial. So through such acts, we decided to put incentives. Then we aim to build the large vision model and graph reasoning modules so that they can enhance our project. Then in the near future, we intend to have an annotated data set strictly from our local waste here, because local waste differs from all aspects, whether you're in northern Uganda, whether you're in central Uganda. So since it differs and we cannot have the same waste in all countries because we do not actually produce the same goods, so different goods are produced with different things, and all those things would require different ways of recycling them. Then we have to ensure that our accuracy of classification of the waste is up to at least 85% to ensure mismatch. Then also, through our project, we intend to have mobile applications so that even on individual basis, whether you have Wi-Fi or not, you're able to classify your waste, and then when you get data, it is updated into the data set so that you can gain back your incentive. So through the large vision models, we shall ensure that we reduce overlapping of waste types. Then build mobile applications for real-time classification and valuation. Through our digital incentive system, we shall ensure that all households and institutions get their time's worth, because even collection of rubbish, let us say like in a mall, if you could say that we are going to give you units, let us say like Yaka units for you to use power, depending on how you've collected rubbish, then those people would actually collect it well to avoid that congestion and dirtiness that is always around malls and shopping centers. And then households, they will benefit through their tokens. Imagine you're given cash back that you can spend on buying other goods, that you can spend, let us say, like on medical services. Then also, we intend to scale it down to what can be used on a mobile phone. So our methodology and system architecture is simply data collection, like from the time you take the picture to as soon as you take the picture, it is simply sent to the large vision model for analysis. Then through graph reasoning, it is going to analyze and classify what you have sent it. Then it is going to, after classification, it is going to value what you've given it and then give you an incentive of an incentive which may be either be positive or negative, depending on how you have sorted your rubbish. Then in the end, we must give people feedback so as to ensure that everyone in the community is learning on the benefits of proper waste management. To ensure this, we shall have our app running to ensure that every user is is given chance to use it.
Yes, good evening, everyone. So I'll start from where my colleague Benedict Wendera stopped, and I'll be explaining the datasets we used. So we used two datasets, and first is a Kitezi landfill dataset from West Sydney University, and it includes a date, amount of waste received, source of collection, which is maybe either KCCA or private collectors. And from our analysis, we saw an upward trend in waste over the years, with spikes during public holidays and festive seasons. So this chart is what you're basing on for the waste quantities, and you can see it's an upward trend in the waste. Yes. So secondly, we used the real waste data set from UCI machine learning. And this data set has over 4,800 labeled waste images covering plastics, food, metals, paper, glass, etc. So this dataset is very useful for training our CNN because it is diverse and much well distributed. But of course, just like any other project, we face some challenges while using these datasets. For example, organic wastes and miscellaneous wastes often look alike, and therefore our model really struggled to differentiate that one. So let's talk about modeling. As earlier noted, our project performs its tasks in three main ways, which is anticipation, valuation, and incentivization. So let's talk about anticipation. So for anticipation, we use linear regression as a baseline model. We include features like year, month, and day of the week. And for all we did for anticipation, our main target was total waste tonnage, which is the total waste accumulated from a particular area. So this model explained about 20% of the variance with a mean absolute error of about 200 tons. Yeah, of course, this isn't perfect, but it's a good starting point, showing patterns that guide planning for our KCC agents in this case. So our next model was, of course, valuation, whereby in this case we trained a convolutional neural network which performed tasks like image resizing, normalization, and augmentation. So our valuation model had a training of about 64% with a validation rate of 16% and a 20% testing rate. Our model, our valuation model learned at a rate of 64% training and validating the data at a rate of 16%. So it really worked well with plastics, glass, and paper, but less so with overlapping categories like organic waste. And my colleague already talked about incentivization, whereby points are awarded for good waste handling, and negative points are, or points are deducted for poor waste handling. So let's talk about the results and insights. So what do we get from all this? So for anticipation, it helps us forecast future waste levels, which supports planning, of course. And the valuation, it helps us classify waste automatically according to the given classes we named, and this supports decisions like recycling or finding. Then, of course, we have to integrate anticipation and valuation, and these together, the system provides a full decision support tool, which can be used by officials for future planning. So let's take a look at maybe an example we can use in this case. Let's say next month, we expect about 1,200 tons of waste from Central Division. And a plastic bottle, of course, is classified as valuable, and therefore it's bought for recycling. And organic waste is classified as non-valuable, and therefore fines are awarded to the responsible individual. Yes. So so for the model selection and deployment, so we chose a regression model because it's simple and easily interpretable, and CNN because it's accurate for large image tasks. So both these models can be integrated into a web dashboard, and the idea is to make it accessible to decision makers like our KCC officers in this case. But of course, just like any other project, we faced a few challenges, and we had a really huge challenge with the datasets, because most of the datasets we found for our particular project were really small, and some of these models couldn't handle unexpected events like strikes, disasters, etc. And I think it may not be well known, but CNN really struggles with overlapping or similar categories. Let me say you have organic waste and miscellaneous waste. It struggles differentiating the two. And also, training these models was computationally expensive. Yeah, we needed quite a number of resources, but yes, thankfully we managed to pull it off. But in the future, we are looking forward to expanding data sets with more local data or data involving more of our environment. And we are looking forward to adding IoT sensors for real-time monitoring and maybe using advanced models like LSTMs for forecasting or maybe building a mobile app for our field offices. And to conclude, I really think Ecoverse shows that AI can support sustainable waste management in Kampala. By combining anticipation, valuation, and incentivization, we have really created a system that is not just technical, but practical for our environment. This work shows potential for smarter, cleaner, and sustainable cities in Uganda. Yeah, and finally, I would like to thank my supervisor, Dr. Melvin Galiwango, for his guidance. Yes, and I want to thank Western Sydney University for providing the GTZ Landfill dataset and the UCI Machine Learning Repository for the Rural Waste dataset. And of course, my lovely subscribers, thank you for listening.